Hello, now let's have a look at file descriptors and redirection. Now, even if you have minimum experience on the Linux command line, my guess is that you know what the greater than sign can be used for. And if you don't, no worries, we'll start with that. But the main purpose of this little exercise is to talk you through what actually happens when you use redirection so that you feel confident because you know about the ins and outs. And the last example will be a very cool example with the help of VI. Just so that we're all on the same page, when you run the ls command, the output will be sent to screen. But if you don't want to get the output on the screen but in a file, you can use the greater than sign to redirect the output to a file. Now before we continue, we need to talk a bit about the concept of the input and output devices of your terminal. When you log into your system and a shell is started on your behalf, this shell will connect to the keyboard and to the screen. The official name of the connection is called a PTS, or a pseudo-terminal. Now if I run ps, I see that I'm connected to PTS0. The next user that logs in will automatically connect to PTS1 and the third to PTS2 and so on. Now it may surprise you, but you can actually view the connections in memory if you like. Let's just do that. Now every Linux system has some file systems that are not on disk but in memory. So these file systems are only there when the system is up and running. And they are called pseudo file systems, and for completion I have listed them in the description of this video, but for now we're only interested in the /proc file system. So here we go. I pick my process ID and cd into it via /proc. So we cd into /proc and then our PID. Now there's a lot of stuff in here, but we're not interested in all of that. We're only interested in the fd directory, which stands for file descriptor. Let's check that out. So we see 0, 1, 2 and 255. This is very nice, look. So it says that all these files are symbolically linked to /dev/pts/0. So whenever any of these numbers is accessed, it will be pts0 that is actually accessed. So the only data in file 0 and file 1 and the others is the path name of pts0. So when I write something to file 0 or 1 or 2 or 255, it will always be written to PTS0, which is my terminal. Now let's go to the drawing board and visualize this. So the keyboard is connected to PTS0, which is connected to our shell, and the screen is also connected to our shell. So the shell listens to the input of the keyboard and sends the output to the screen. These are referred to as standard input and standard output, or std in and std out. Now there's a third one, which is the standard error. So the output as well as the error messages go to the screen. So the default input is file descriptor 0, the default output is file descriptor 1, and the default error is file descriptor 2. Now I'm back in my login directory and I see two files. Then I redirect the output to another file. So I run ls greater than list. Now if I list a file that doesn't exist, it will print the error to my screen. And if I don't want to see this error, I can redirect it by sending it to another file name or maybe even to the bit bucket so that it will disappear forever. Now, if I want to redirect both output and errors, I have two options. I can redirect them independently, so I redirect all file names to a file called list and the errors to the bit bucket. Or I can redirect them both to the same file by using the ampersand. So this will send the errors to the same file as where my default output is being redirected to. And finally, to see file descriptors in action, I open VI and then I start a shell from VI. I list my PIDs, I cd into the process ID of the VI session, and in the file descriptor directory, I see the VI process has file descriptor 3 linked to the file I'm editing. And we're done.